Hey everyone, Geophysicist Stefan Burns here. We just had a magnitude 6.9 earthquake strike just south of Iceland today, April 3rd. And this is just a couple days after some new volcanism started up in Iceland. And it's also one day before we have a very notable planetary alignment. We have Mars exactly trine to Saturn, and we have Uranus in the middle of the two sextile to both. So that's a 120-degree angle between Mars and Saturn, and a 60-degree angle from Uranus to both Saturn and also to Mars. And this is very much an archetypal signature of things like earthquakes. But why are we having such a powerful burst of earthquake activity around the globe now for about 2 weeks? Well, the answer may lie with the sun, because we had a very significant solar event that occurred earlier back at the end of March. Actually, two significant events. We had the largest coronal hole on the sun that we've seen in probably about 9+ years. And then we also had a mega coronal mass ejection. And so check out this earthquake clustering that has occurred over the past 30 days or so. Here we are looking at some data, all earthquakes greater than magnitude 6, greater than equal to magnitude 6, and we have our sunspot number here. And so it's green, that's the complete sunspot number for the month of March, though we are missing the 1st of March with this data. And then we see our preliminary sunspot numbers here for the beginning of April. But here we have a magnitude 6, a magnitude 6.5 earthquake clustered around this low in sunspots. Look at how there's no earthquakes greater than or equal to magnitude 6 during the sunspot high. And then with the appearance of this coronal hole, which we see here. Here's the coronal hole. This is for March 24th at 2010 Universal Time. And so this was just starting to enter into the geo-effective position, because it needs to be a little bit more here on the sun for that high-speed stream that emits to connect to the Earth via the Parker spiral dynamics of the solar wind and the interplanetary magnetic field. But right when it appeared, it started appearing around the 22nd, 21st, 20th, we start get these earthquakes. Check out this sequence, magnitude 6.2, 6.5, 6.2. That all occurred in 3 minutes right there. That's Alaska and also, I believe that's Panama. And then we see this massive drop in sunspots going down to 50. The reason why is because you don't have sunspots in a coronal hole, and this is so large it covered up a pretty large majority of the sun. And as a result, you only get these sunspots there on the edge and sunspots there. And so you get this really big drop in sunspots. We're just looking at sunspots as a way to kind of understand solar activity. But we see this big drop in sunspots, and that's when the earthquake started to really rumble. We get the 6.7 there, New Zealand, 6.1 on an oceanic ridge. Look at this clustering that happened on the 28th. We had the 7.7 and the 6.7 aftershock in Burma, Myanmar, also Thailand had a lot of shaking. Then we had a magnitude 6.1 and magnitude 6.6 on the mid-Atlantic ridge. And then since then, we've had a continuous release of high magnitude seismic energy, whereas we haven't been having magnitude 6s all that often in 2025 until really this started. So following up after that, we have a magnitude 7 and a magnitude 6.2 in Tonga, then a magnitude 6.3 on a ocean ridge, a 6.2 in Japan, and then today's 6.9. So a crazy clustering of earthquakes after that high-speed stream from the coronal hole came in, because here is that G2 storm triggered by that high-speed stream, and the characteristics of the high-speed stream were quite anomalous. The solar wind density dropped to anomalously low levels of under 1 particle per cubic centimeter, or even below 0.2 particles per cubic centimeter, which are levels that we almost never see. So we had this increase in the solar wind velocity. We had first this high density shock hit the planet called a co-rotating interaction region, a CIR. That gave us our initial spike in geomagnetic volatility, and then the solar wind velocity raised up and the density dropped dramatically, creating a bit of an energy vacuum. And that's when all these earthquakes really started to pop off. We see connections between coronal hole high-speed stream impacts and earthquakes. And this data, just for the past 30 days, demonstrates that brilliantly. But it's not the only thing that has happened. Check this out. We've also had a proton radiation storm. So we had an S2 proton radiation storm. This is data for the past 7 days. We're looking at proton flux as measured at 5.6 Earth radii in the outer radiation belt, an electron dominant belt. Typically doesn't get saturated with protons, but during a solar energetic particle event like a proton radiation storm, the flux on things like protons can go up dramatically. And so we had that mega coronal mass ejection back on the 28th. Let me actually pull that up for you, because just to get your eyes on it really quickly, because that was a real shock in many ways. Here is the, actually I think the data is right here. Let's see if I can get this. Here is the crazy coronal mass ejection that we had back on the 28th. This is what triggered that proton radiation storm. So you see it's just really, really gnarly. I mean, look at that. That then sent out a shockwave across the entire solar system. This is a large enough coronal mass ejection that effectively the entire solar system received a solar energetic particle event. This was aimed directly at Jupiter. Look at the density of the plasma. Even like chunks of plasma were like ejected out from this crazy coronal mass ejection. That's what triggered this proton radiation storm, which went up to S2 values and then decreased down. And so what does that mean? Well, let's look at the actual flux rate. We reached about 140, 135, 140 for the greater than 10 mega electron volt protons, whereas normal values, as we see with our higher energy protons, greater than 50 mega electron volts, greater than 100 mega electron volts, they are about normally 0.2. So dramatic increase in flux. We're talking, if you go from 0.2, we're talking just a little bit less than a 1,000 times increase, right? A 1,000% increase. A 1,000x, because you go from 0.2 to 2, that's 10x. Then you go from 2 to 20, that's 10x, that's 100x. And then you go from 20 to 200. This is just under 200. So a massive increase in proton flux. And that in general charges the planet, specifically in the polar regions. And you just have more energy coming in. And so we see this big release of energy from the sun. We see this anomalous solar wind conditions. We see the giant coronal hole high-speed stream, which has a connection to giant earthquakes, very high magnitude earthquakes. And then we see what's been happening. We see this global seismic burst. So here we can actually look at that global seismic data really nicely. This, what I'm calling a global seismic burst, because that's what it is. Plate tectonics has been accelerating. Now, this is not a, I don't think it's going to be a long-term acceleration, like decades or something like that. But plate tectonics is the movement of the plates around the globe, right? How they're moving. We're going to look at some really interesting photos from Burma, Myanmar in just a second. But when there's not that many earthquakes, plate tectonics is, a slower process. Well, when you get a whole bunch of earthquakes, it's a faster process. We saw this data before. Here we see a magnitude 7.1. That was in Nepal. This is like the beginning of January. We see basically up until this seismic burst right here, we had just a temporary increase in the combined seismic energy. And most of that energy is going to come from a high magnitude earthquake. And then it goes down. Then we see there another bump up, it goes down. You do see at times overall number of earthquakes go up, like we see here around the 7.6. That time frame just in general saw a higher number of earthquakes. And look, it's actually kind of interesting how we had a higher number of earthquakes right before the 7.6. And then on the day of the 7.6, southwest of the Cayman Islands, the number of earthquakes went down, but the total seismic energy release went up. And then the number of earthquakes went up again on the other side. That's a little interesting for something, something for someone to explore more if they want to. But then things basically went back to the baseline where they were. But then we see these waves of increased seismic energy starting to come in. Really, so far the climax has been that magnitude 7.7 in Burma, Myanmar, and the other 3 magnitude 6.0 plus earthquakes that occurred that day. But then we had this magnitude 7 in Tonga, and now this 6.9 just south of Iceland. And so you see this seismic burst. At least for 2025, this is definitely quite a lot different than what we've seen thus far this year. And in general, I would say this is the most seismic activity that we've been seeing globally since probably the 7.8 and 7.5 earthquake sequence that occurred in Turkey back in February of 2020. What was that, 2023? Yeah, so really, really quite striking here. And let's actually look at that slip that occurred, because this is really, really shows you just like how a very powerful earthquake, how much it actually affects the Earth on a human time scale. So we can actually see the displacement along the roads, and this one's really striking. Look at the displacement in the city along that fault line in Myanmar, before and after the earthquake. Here we have the 25th of March, and then we have the 30th of March, right? So we see also, this is a bit more zoomed out here. That's why the change doesn't look as dramatic as these images here. But you can see that movement right along here as well, especially up there. See that? Like, these are satellite images showing the movement of basically the Earth, right, along that fault. And so when you have an earthquake, that's what occurs. You have slip along a fault. And you'll have some sort of lateral displacement typically, like we see here, but often you also have a more of a vertical displacement too. So you have like a horizontal displacement, right, like this, and then you also have like a vertical displacement, either normal or reverse faulting. And the strongest earthquakes will be normal or reverse. So really, really significant slip from that magnitude 7.7 and from the aftershocks that occur, but primarily from that 7.7. That's where most of the energy is. But today we had this magnitude 6.9. We can check out, which is, right up there. We can check out how that seismic energy swept across the United States with our graphic here. So check this out. This is actually really close to North America, this earthquake that occurred just south of Iceland, right? Or there's Iceland right there. This is along the mid-ocean ridge. And that's actually what I kind of want to talk about today in this video, about how it's kind of bizarre. We've had so many earthquakes along the mid-ocean ridges since that high-speed stream impact. That's where you have the plates spreading apart. So the magnitude 7.7 in Myanmar, Burma, that was along a normal fault, right? Within a continental interior, but we're having a lot of magnitude 6.0 plus earthquakes along oceanic ridges, and they do get earthquakes over magnitude 6, but they don't get them that frequently. It is, it's not impossible. They happen. We'll look at some historical data, but it's not like they happen every day. But just over the past 2 weeks, it's like we've had them every single day. And, at oceanic spreading centers, mid-ocean ridges, that is where we see the actual convective cycle of the mantle expressing itself at the surface, because you have the plates spreading apart like this. So it is quite incredible that we're having so many high magnitude earthquakes along these spreading centers. And it's not just one single spreading center too, like the Mid-Atlantic Ridge, but also like the Pacific Antarctic Ridge, and like just in general across the globe after that high-speed stream impact. And just slightly before, but with the appearance of that coronal hole in the sun, we've had a lot of high magnitude earthquakes along spreading centers. Look at the displacement though, along just the seismic energy sweeping through North America. Let's go to that again. We look down here, we see our trace, this is our reference station. We see first the P wave and then the S waves coming in, and then we see the surface waves, which are the slowest velocity. That's all shear waves right there. But then we get the surface waves, and look at how it really starts to oscillate things. Like, check that out. Really high magnitude swings up and down. Our red is up, our blue is down. So we see the vertical displacement here from that 6.9 earthquake. And that 7.6 that occurred just south of the Cayman Islands, right around, what was it, like right around here, something like that. That was also fairly close to North America. So it went up like this. This one is going down like that. Those are the earthquakes closest to North America of high magnitude just recently. The 7.6 being back in February. But that's the seismic energy as it ripples through. And I think I want to show you now. Yeah, now let's look at the USGS data, because I have this graphic here showing all these earthquakes. So let's look at the map for that, okay? So we can really see how many have been on these oceanic ridges, because it really is quite phenomenal. Here we go. Here's our USGS latest earthquakes map. I actually have this set going back to March 2nd, which corresponds to that data graphic that I made. And we have it set for newest earthquakes. We see the magnitude 6 point. I also have this set for magnitude 6 and greater. So we've had like magnitude 5.9s. We just had a magnitude 5.9 in Indonesia. We've had like some high magnitude 5s as well, but you have to create a limit at some point. So the limit for this is magnitude 6 plus. And that's a good limit, because you know, magnitude 5s typically have one a day. Sometimes you don't, but typically you have at least one a day. But magnitude 6s are a bit more rare. They're not anomalously rare, right? A magnitude 7 is a little anomalously rare. You know, they don't occur that frequently. Magnitude 8s, really rare. Magnitude 9s, very, very rare, but they happen. But here, just look at this. This is a 6.5 on Jan Mayen. There's a volcano right there along that part of the spreading center. And this is the Mid-Atlantic Ridge. So this goes all the way from Gockel Ridge right here, where there's a supervolcano. At least there used to be, and there's still evidence of there being active supervolcano activity there along Gockel Ridge. It goes all the way from Gockel Ridge through the Arctic down to the Mid-Atlantic Ridge. And so we had the 6.5 that occurred on what was it, the 10th of March. And then we had just this one today, the 6.9. And then here is the location of the 6.6 and the 6.1. If you zoom in, you see that other 6.1. Those both occurred on the 28th. That is our Mid-Atlantic Ridge. But now we can zoom over here. We see that we also had this magnitude 6.3 just yesterday on the Pacific Antarctic Ridge. And we'll see quite a lot of activity actually around New Zealand in general. If we go here, there's again that magnitude 6.3. Here was a magnitude 6.7 New Zealand. This was the 25th of March. And then here's our magnitude 7 and 7.0 in Tonga, right next to the Hunga Tonga volcano. The submarine volcano exploded January 15, 2022, with the biggest eruption in the 21st century. We also just had an earthquake in Japan. I haven't covered that one yet. It's right here, 6.2. That was also yesterday. We had two magnitude 6 plus 0 earthquakes yesterday, 6.2 in Japan, 6.3 along the ridge, the Pacific Antarctic Ridge. And then we also, of course, see the big daddy of all of them, the 7.7 in Burma with the 6.7 aftershock, and many other aftershocks too. So those are the primary earthquakes that occurred. Of course, we also have these ones here, Panama 6.5 and a 6.2 that ruptured simultaneously, and this magnitude 6.0 in Chile. This is the oldest one going back to March 6th for this time frame. Again, March 2nd all the way up to today. Now, if we go to this other map right here, this is all the earthquakes historically along the Mid-Atlantic Ridge. I drew a box basically going from here down to there, okay? So this is not the entire globe, but I just drew a box, and this is set for January 1st, 2020 to now. And we do get two earthquakes that show up there in Morocco just because of how the box is drawn, but we can just ignore them because we're only focused on the ridge with this data set. But the largest magnitude earthquake of all these in this zone going back to January 1st of 2020 is the earthquake today, the 6.9 along the ridge right there. So we zoom in, we see that there's this other magnitude 6.0 that occurred close by on the 10th of, on the 1st of October. I believe that should be the 1st of October. And then that was in 2022. But if we go here, we see this central Mid-Atlantic Ridge earthquake 6.9. We see a lot of earthquakes right there in that zone. Which is interesting because that's right where the continents are really spreading apart, right? You have Africa, you have South America. That's where they're really spreading apart, right there in that zone. That's where we get a lot of high magnitude earthquakes. But we also get these earthquakes that have been corresponding with coronal holes. So it's not just today or just past 2 weeks where we've had these coronal holes and then these earthquakes. It actually goes back in time. So I can pull up some examples for you, okay? We have and we'll start with the oldest one here. Just 3 examples. I didn't go through all of them. Here we have August 30th, 2022, a magnitude 6.5. And let's just kind of punch that in a little bit. So here is August 30th, 2020. And let's find the earthquake for it. But first off, notice the big coronal hole there. And then in general, because it's solar minimum, there's just in general a little bit of, more of an open field configuration across the sun. But a big coronal hole there. If we go back here, that was August 30th of 2020. Is that right? Yeah, August 30th of 2020. And so we can sort by oldest. And we'll see that that was a big earthquake, a 6.5 right there. So that corresponded with a coronal hole high-speed stream, or at least the appearance of a coronal hole. Then we can go forward to the next example that I pulled up. Basically, I just typed in some of these dates and they all had coronal holes. That's effectively, and at some point I was like, I can't go through 20 different examples, so this would be sufficient. Here we have March 22nd, 2022. We see these coronal holes there and also there. So there we have 3 coronal holes on the sun. We don't have the biggest one like we saw just recently, but we have 3 significant coronal holes right in that central zone. This is March 22nd, 2022. And if we go forward, we'll find that earthquake 6.7 along the mid-Atlantic ridge, okay? Right there. Let's go to the next one. And that is September 4th, 2022. Also, so notice both of those are around equinox, right? So hint, hint. We can look at that. Here we have, again, coronal holes. One up there, another there, and then this guy. And this is in the geoeffective position. These 2 are just entering into it, though this is up in the hemisphere, right? But also, again, coronal holes. And what earthquake did that correspond to? That is September 4th, 2022. And we see that that was a 6.9 right there. So yeah, these high magnitude earthquakes along oceanic ridges, these spreading centers, at least just with the few that I looked at, and also the one that just happened, are all connected to coronal holes and their high-speed streams. And if we go back one more time to this graphic, I just think that this graphic really drives it home. Like how can you not look at that and see the connection? Especially when you take into consideration the seismic energy of a 7.7 or 7 or 6.9 in relation to these other earthquakes, which are lower magnitude, right? It scales really quickly. It's not linear in terms of how the energy scales. So there's a tremendous amount of energy released with that 7.7, that 7, and that 6.9 compared to like a 6.2 or the magnitude 6. That all occurred with the appearance of that coronal hole and also the downstream effects of that afterwards. And here we have our sun in 211 angstroms, and we see, first thing I noticed when I've been looking at the sun recently is this interesting configuration with these active spots, right? 1, 2, 3. It's almost like making a cross on the sun, like a perfect like square cross, like from the medieval times. But we see some more coronal holes, not big like the other one, but we see this coronal hole there, we see a coronal hole there, we see a little bit of action there as well. And what we see is that sunspots are connected in location to these coronal holes, like they're close by, typically are a bit more active. It was this sunspot group right there that gave us that 1.1 x-cos flare and that mega coronal mass ejection, which gave us that S2 proton radiation storm, which just now is finishing up, right? We're back below the radiation threshold warning of S1, but there still is elevated proton flux at this moment in time. But we see that we have new activity rotating in, and these guys are just about Earth center direct right now. We can look at our, let's look at our latest sunspot intensitygram so we can see this. And tomorrow is when we have the significant planetary geometry, so we'll talk about that just in a second. But here we have 4046, here's 4048, almost now becoming like 2 different clusters, though I don't think they've split the sunspot number on that. It's just when solar flux is pushing out of the sun, it'll spread apart like this. So that's why you get that. This used to be clustered more closely together, but still a very significant sunspot. If I punch in on that for you all, you can see that. We have that Earth center and direct tomorrow, and that is when we have this Saturn and Uranus and Mars perfect arrangement. And that is the Saturn-Uranus sextile is the final one of the synodic cycle. It's a closing sextile that's been building since 2023 for like 2 years now. It goes exact tomorrow, Friday, April 4th. And Mars happens to be configured to that. Mars being perfectly trine to Saturn and perfectly sextile to Uranus. So that's a very significant planetary geometry. Let's actually check that out on Solar System Scope. There it is. Welcome to the solar system. All right, let us go. This is our local neighborhood, folks. Like, how does this not affect us, right? Especially once you research into quantum physics. And there's a lot of different hypotheses with quantum physics, a lot of different ideas, but effectively, you can ask yourself the question of like, okay, we have the sun, we have these big changes occurring with the sun in terms of the really big coronal hole, that mega coronal mass ejection. Then we've had all these earthquakes and the clustering of that. Is there some more foundational factor that was a trigger to all of this rather than the sun just being the primary agent of chaos, you could say? How are things manifesting out of more implicate orders? These are orders that are a little bit more differentiated beyond just space and time. Different dimensions, higher dimensions, and then they manifest into the explicate order. This is the idea that's put out by Bohm, David Bohm, who I think is really worth studying and researching into. I just really resonate with his ideas and his kind of philosophy of things. But here we have our solar system. And again, we're looking at, if we kind of look at this a little differently, we're looking at an electromagnetic field, we're looking at a gravitational field. And the only things that really affect that field are the points within this system, right? You don't really have an influence, a generating influence of gravity or electromagnetism just in empty space. You have the sun creating the solar wind, which has this interplanetary magnetic field, which connects all the planets together. And then you have Jupiter having an extremely powerful electromagnetic field. You have Uranus and you have Saturn and Neptune all having powerful electromagnetic fields. The Earth is right there next in line. It has the strongest magnetic field outside of the gas giants. Mercury's field is only 1/100th the strength of Earth. Earth is the closest to the sun though, right? Jupiter's at 5 astronomical units. Uranus is at 20, Neptune's at 30, Saturn's at 10 astronomical units. So we have this pretty strong magnetic field right next to the Earth, right next to the sun. And so they're all working together and connected together through the solar wind. And then you have the gravitational influences too. Again, empty space, you're not going to get a gravitational force there being exerted from empty space because there's no mass. Only the planets have mass. So you have to kind of look at it from that perspective and not necessarily from, oh, we're going to calculate the gravitational significance from there to there. Like, you can do that and that's important, but you can also just look at it as like, okay, who are the only gravitational and electromagnetic players in our local space? It's the planets and the sun. Okay, this is just kind of, how I see things. This is just my perspective. So here we have the Earth, we see Saturn, we see Uranus there. They are in that sextile. If you zoom forward just one day, it goes exact. So that should do it right there. But you'll also notice Mars. Where is Mars? Oh, there's Mars. So if we have to kind of zoom it like this because Mars is actually quite a bit closer. But if and let me actually turn this off. Yeah. So now we can see this arrangement of Saturn sextile to Uranus, and then Uranus sextile to Mars, and Mars being in a 120-degree orientation with Saturn. And so if we do examine the archetypal influence of that, Saturn relates to the material world. Structures, boundaries, and limits. And what is plate tectonics, right? It's the actual boundaries between plates, okay? Like, you have these solid continents and plates, and then you have the boundaries between them, whereas there's this active flow of energy from deeper within the planet. Saturn is very much connected to all of that. If you just examine its archetypal symbology in history, you could say, which has been, figured out over thousands and thousands of years. Let's not forget that back 10,000 years ago, there was no distinction and differentiation between astronomy and astrology. They are one and the same thing. It's only our modern perspective which has split them apart into different things. Like, it's the oldest science. This is just, once you study into it, it starts to make sense. You have to actually really study into it though. You can't just like, touch it for 10 minutes and be like, oh, it's hogwash. Like, you have to actually study it like a scientist, and then it makes sense. You have to have your right brains be a little open, right? You have to embrace your intuitive side for that to make sense as well. But it does. Saturn, again, connected to like material reality, structure, form, boundaries, things of this nature. In a sextile to Uranus, which is a planet connected to disruption and change and electricity and earthquakes and just sudden disruptive changes. It's in an Earth sign if we go by Western tropical astrology. So it's very much like perfectly positioned to be like a reference point for earthquakes, for example. Just it's really resonating with that message at this moment in time because of its location. And then Mars here is a planet of like disruption and energy and just kind of volatility and just like energizes things. It's very aggressive. So you have that all working together, and Mars and Saturn are also the two malefics. So they're not necessarily the good guys. Now, at the end of the day, good guys, bad guys, right? It's all just a distinction and a mindset, right? They're good and bad. If you go to a non-dual perspective, we can see beyond it, right? But this already is a pretty energized combination because this is the end of the synodic cycle. Saturn will catch up to Uranus. If I zoom forward here, it may take some time, but see how Saturn's catching up to Uranus like that? They're going to have a reset of their synodic cycle in 2032. So that's some time away. And now I'm going to have to go back here to get to the present day. But Mars just adds more energy into the mix, and it's going direct too as well. So it's now not going retrograde, it's forward moving, and that means that it's now applying its energy more efficiently. So we have this whole thing coming up tomorrow. These energies can be felt before, they can be felt afterwards. It doesn't mean exactly we're destined to have something big tomorrow when this all configuration goes exact. But that is the top of the waveform. If we look at this like a wave structure, right? That is the top of the waveform. This wave has been building since, again, April or about spring of 2023, and Mars is sliding in to participate at the last moment as well. So yeah, really, really quite phenomenal planetary geometry that we have coming up tomorrow, and we are seeing this ongoing earthquake burst globally now for about 2 weeks. Again, just look at that data. It's insane. I make these every now and then where I take the sunspots and I compile all the earthquakes greater than magnitude 6 or sometimes greater than magnitude 5.5. And you get this sort of clustering basically every single time around some periods where sunspot numbers are low. But this is the craziest one I've made thus far. So very wild. I just want to see, I think there's maybe some other stuff to show you. Well, we can look here. Let's look at our X-ray flux really quick. We actually haven't had much solar activity from 4046 and 4048 in the past 2 days, though we did have some high M-class flares, mid M-class, higher M-class flare there on the 1st of April. But since then, we haven't gone above into M-class territory. So they have been kind of simmering, you could say, since the 2nd of April, and here's today. We see that it's really not all that notable there, but that could change. And if I had to bet, I'm not saying this is the highest likelihood or anything like that, but if I had to bet, I would say that tomorrow would be the day that we get something popping off in terms of a solar flare, just because of the planetary geometry being one of those forces, especially as Mars configured, Uranus, Saturn. Again, I talked about it already. Again, not guaranteed. But, I would just, in my mind, if I'm a betting man, I'd just put a little bit more chips on that probability. Doesn't mean it's going to work out, play out, could lose those chips, but I would put a little bit more there because of just all these other factors that are currently at play. There are ongoing changes that are occurring to our magnetic field. I've released my Earth's Magnetic Field Master Guide video yesterday, a 2-hour lecture on Earth's magnetic field, everything about it, talking about the movement of the poles. This is all in connection to this, right? Earth's magnetic field is a great mediator of all this energy coming in from outer space. Whether this is from the sun, that's the primary dominant by far energy source that the Earth receives, but also from, let's say, like cosmic particles. They're routed by magnetic fields. So Earth's magnetic field, which connects to us very deeply, biologically, biophysically, bioelectrically, is the great connecting agent to all of that. So I would highly recommend everyone to watch through that 2-hour lecture. I have it all chaptered out so you can watch it in chunks, but you definitely, if you want to understand the direction that we're going on this planet in terms of these many paradigm shifts that are unfolding, then you really need to learn about Earth's magnetic field deeply, and not just with like a TikTok or a 3-minute video, but with like a proper 2-hour lecture. And then actually my Earth's magnetic field video playlist has other videos. There's a one on Earth's magnetic field strength that's an hour long. I have a video on magnetic anomalies that's like 30+ minutes long. So I have some really, really in-depth resources available for you on Earth's magnetic field. But I want to touch on this because a lot of people look at this and they get concerned about the movement of the magnetic pole. And it has been accelerating rapidly, though it's now deaccelerating. Just in the past 10 years, it has started to slow down. You can see that at the very end of this animation. If you watch closely, you'll see it's fastest in the 90s and early 2000s, and then it does start to slow down right near the end. See that? It is starting to slow down based on our best measurements. But there's an interesting thing, actually, I want to point out about Earth's magnetic field that hopefully will alleviate some concerns for people. Because this is actually the closest that the magnetic North Pole has been to the actual North Pole in a long time, right? So, yeah, it's been moving quickly, but it's actually very close to the North Pole, which would be the ideal location, right? If we had the perfect dipole, if Earth's magnetic field is a perfect dipole, you'd expect it to be right near the North Pole. So the fact that it's very close to that, right, it hasn't gone into, for example, into China or something like that. If it's really down here, if we're measuring the magnetic pole, the one in the northern hemisphere, actually now in a mid-latitude region, yeah, we're 100% in a geomagnetic excursion. But it's actually super close to the the North Pole in the northern hemisphere. But what's really interesting is, okay, so we have the magnetic pole in the northern hemisphere right about here. This is a rough approximation. It's right about here. Okay, you see that location. Now we have the one for the South Pole. Where is it? It's right about here. So the one on the South Pole is the one that's offset. I think it's actually more like here. That's the one that's a little further offset. See that? We have one close to the pole, one is more offset. Back about 100 years ago, it was actually the exact opposite. We had the magnetic pole in the northern hemisphere offset because it was in Canada about here. And then the magnetic pole in Antarctica was actually a lot closer to the South Pole. Exactly. It was more in the continental interior of Antarctica, just about this zone, right? These are not exact with my fingers, but pretty close. So if I get this lined up, we see that offset. So they've really just swapped in terms of their offset. Now we have the offset in the southern hemisphere off the coast of Antarctica, and the North Magnetic Pole is right close to the North Pole. And just 100 years ago, it was the opposite. So, you could make the argument that 100 years ago was just as crazy with the magnetic field as it is right now. There was a big period of acceleration for the magnetic pole in the southern hemisphere, going from 1900 to about 1990, and then it started to slow down. So I just find that, and actually even going back earlier before 1900, but we have to keep these things in our mind and our perspective. We can't just look at just this and freak out. If you look at even just the past 100 years, we've just effectively changed places, and there's, it's just not that big of a deal, actually. I don't think so. Now, if things actually start to get concerning with this, I'll be the first person to let you know. So let us do a question and answer. If you have any questions, please ask them. I will do my best to answer them. We'll do a short question and answer, and then I'm going to sign off. And that's what's been happening. It's been a lot of energy on our planet since that coronal hole high-speed stream. A lot of seismic energy getting released, which has been quite notable. I mean, just to have that much is really, it's notable. We haven't had a release of earthquake energy like this, seismic energy, in a while. So we'll see how much longer this continues. But the next big thing we have coming up is the planetary geometry between Saturn, Uranus, and Mars tomorrow. And then after that, maybe things will start to cool off. We'll see. We'll see. So a question from Cosmic Zeal is, what would people feel if they were in a boat or a ship between South America and Africa during a 6.5 or 7 magnitude earthquake? Well, it depends if there's any like displacement of the water. But if you're way out at sea, even a big earthquake creating a tsunami will only be a tiny little blip on the ocean. So they're not going to feel anything. And a question from Sally is, do you think the solar activity will set off any seismicity off the coast of Washington and with Mount Rainier? We do see, we see a pretty good connection based on the research and just some of these trends I pointed out today. Pretty good connection between solar activity and earthquakes. That connection is not as well established for volcanoes, though I personally think that makes sense. And there's probably some research out there. I haven't read on that yet. I'm sure there is, so I should get on that. But we see that research really pretty nice and strong for earthquakes and solar activity. For volcanoes, it's a little bit of a different story, but for specific locations, I think it's kind of hard to forecast. We just have to look at it from a global perspective. But we do know that there's a lot of volcanoes in Washington, and this Cascadia subduction zone is due for a big one, so it's an open question. And a question from Sandy is, do you know when we may have the solar flare that takes down our power grid? We don't know when the next really big, high strength solar flare that's Earth directed will be. We do have perhaps an ability to forecast it a little bit using planetary geometry. I forecasted a geomagnetic disturbance back on March 2nd for March 23rd to 25th, and we had that G2 storm roll through because of that coronal hole high-speed stream on the 26th. And so that was pretty good. We also did have a coronal mass ejection impact during that 23rd to 25th time frame, though it was quite weak, did not get us to a G1 threshold. But in terms of like a super flare that takes down the power grid, we don't know if the power grid is going to collapse, right? It's shown to be quite resilient, in fact. And B, forecasting when a super flare will occur is something we just don't have the capability of. And that's just true. We just don't have the capability of forecasting that. If we see a massive sunspot appear on the sun, then maybe we can forecast it out to a higher probability 3 days in advance or 4 days in advance. But in terms of like, in 20 years we're gonna have a super flare, that's just bogus, based on the best research and what we know. Okay, here's a question from Cam, which is, with all the recent activity, is our atmosphere/ionosphere in good enough shape to protect us against something like the X-class flare we recently saw? Yeah, like we've had an ionosphere on this planet for a very long time. They theorize that it formed very quickly after the accretion phase of the Earth, like very quickly that ionosphere formed. And it absorbs all that X-ray radiation and beyond. Extreme ultraviolet, X-ray, and even gamma rays. It absorbs all that from anything outside the Earth, like a gamma ray burst or like from a solar flare. It also absorbs a vast majority of the solar energetic particles that will stream in from a solar storm impact or from a proton radiation storm, like a solar energetic particle event, things of that nature. It absorbs all that, thankfully. Now, it formats that energy, and the Earth has to work with that energy in other ways. But in terms of the initial impact, the ionosphere and the atmosphere absorb that. One of the concerns, though, and we can switch our video here, is how the ionosphere and atmosphere are changing based on all these satellites that exist. And there's a whole bunch of things there I've talked about before. I'm just going to touch on it briefly. But the thing is that we're having like 2 to 3 Starlink re-entries every single day now. Each Starlink, this is just Starlink, but there's going to be multiple mega constellations, 10,000, 20,000, 40,000 plus satellites in a single mega constellation. A Starlink satellite weighs about 1,200 kilograms. It's mostly made up of aluminum. So you have, just in general, chunks of this stuff raining down, but a lot of it will vaporize into different, like, more constituent particles, like aluminum, just like aluminum ions, Al3+, Well, it's going to react. A lot of that's going to react. Most of those ions will not stay charged and ionized. They will react with oxygen. Nitrogen's very stable. Nitrogen N2 is not going away, right? It's not reacting with anything. It's like, yo, I got my other nitrogen, I'm good. Oxygen is the one that likes to react, and 20% of the atmosphere or so is oxygen. So all this aluminum, this mass that we put up into low Earth orbit and beyond will connect and bind to that oxygen. You'll create aluminum oxide. That's going to degrade the ozone layer. We've already seen that starting to occur. So the ozone layer getting weaker and weaker is going to protect us less and less from ultraviolet radiation. And that also is an important component in terms of how we respond to solar activity and things of that nature. So this is a serious problem, unfortunately, but this is a serious problem now, and it's only going to get more serious as we go forward in time. And Lisa's asking, if power goes out during solar flare power outages, will solar panels still work to charge power banks? So it depends on basically, a really powerful solar storm, like a really big one, basically creates an electromagnetic pulse globally. It's going to be more concentrated in the polar regions, but it effectively creates an electromagnetic pulse. And the way that it can disrupt things is that it can locally create too much charge flowing through any circuit. Anything that's conductive that forms the circuit can get energized with some of that energy coming in from outer space, from the sun. And so if you have too much charge flowing through a circuit, it can short circuit it, right? And break the circuit. Now the electronics are broken until you fix that short circuit, right? That's why we have circuit breakers, things of that nature. One of the ways that a power grid can fail is that you have these geomagnetically induced currents along the transmission lines and going through transformers and things of this nature. But for like a smaller scale electronics, there's less of a risk because the stronger geomagnetic currents will form along really long conductors, like hundreds of kilometers long, again, like these transmission lines. So if you have your own like solar panel setup on your home and a big solar storm hits, you're probably not going to have any issues with like your solar panels or your electrical system short circuiting, especially if it's very well grounded. It's the bigger power systems that are have problems. So decentralized smaller power systems will likely be fine. It's the big boys that could, with like a super flare impact or like a Carrington level impact, those are ones that could have problems. And Mega Ape is asking, are we in solar maximum right now? Yeah, so we are still in solar maximum, though some people think that we may be past the actual peak maximum phase. We can look at the data really quick, but we just don't know yet. We'll have more information by the end of next year. Here we have our solar cycle progression, and I'm going to zoom out on this data here so we can see our past 3 solar cycles. That about does it. Let's just do this a little bit. Okay, here we have our solar cycle progression. We see solar cycle 23, we see 24, here's 25. We see this big spike there. That was August of 2024. Sunspot numbers about 215 for the month. And that was definitely the highest sunspot numbers that we've had for the solar cycle. Now we're on a downtrend from that local high, that all-time high for sunspot numbers there, August 2024. But if we look at our past 2 solar cycles, we notice that we have a double top pattern. Solar cycle 23 reached this high, formed a low, and then went up again. And then solar cycle 24 quickly reached a high, went down, and then also went up again. And actually for solar cycle 24, that second peak was slightly higher than the first one, a little bit of an opposite situation for solar cycle 23. But we are still well within this range there where we could have a double top. And in general, solar maximum is going to be defined by that period. Like this period from here to there is solar maximum for solar cycle 23. If we go back to 24, we even zoom in on that a little bit. Here is solar maximum going from basically there to there. So we are still in the overall solar maximum, but in terms of like a monthly solar maximum peak, perhaps that was August of 2024 with that data right there. But it's very possible. It's very possible that we get a second peak and then we really start to decline down. If that second peak was to occur, it's going to occur in 2025 or probably early to the middle of 2026. So we could just be on our downtrend now, but we could again have a second, bubbling up of activity from the sun, sunspots going over 150, maybe even over 200 for the month. That's very possible. Someone's asking about the Earth crust displacement idea, and there's no evidence of that. Based on the research that I've done, if that had occurred, there would be evidence globally. Because here we go. We can see this displacement from a magnitude 7.7 earthquake, right? You notice that it's like horizontal displacement like this. Now, can you get the crust to slip across the mantle in like a dramatic fashion, like hundreds of miles or kilometers or thousands of kilometers, some massive crustal displacement? If that was the case, we would have evidence of that. Like we can track earthquakes back across time just on slips like this in the geologic record. If there was some massive crustal displacement, you'd imagine that the geologic record would be completely sheared and torn, because you're not just going to get displacement perfectly along the crust mantle boundary. That's actually a transition zone too. You have like the asthenosphere, all this stuff. You're going to get so many fractures and slips and breaks and everything, ruptures everywhere across the globe if that was to occur. And we just don't see that. So it's really a pretty bogus idea. I don't see any evidence for that. I think it's an interesting idea, right? I hope that doesn't happen. I think that we really have to hope that doesn't happen, but there's no evidence for that based on all the research. And I think there would be definitely evidence of that if that was true. So that's the last question that I'll take. Thank you all so much for watching. I hope you found this video valuable. Lots of earthquakes. Let's go back to this graphic one more time. Tons of earthquakes over the past 2 weeks. The global seismic burst continues. A lot of these along mid-ocean ridges. So there does seem to be this connection between the energy from a coronal hole high-speed stream, at least for this just most recent 2 weeks. There seems to be a connection between the high-speed stream impact that we had, the anomalously low solar wind density, and also earthquakes along the plate boundary, specifically the oceanic spreading centers, which is where that convection comes up from the mantle. So some interesting energy dynamics unfolding across the Earth at this moment in time. And we have some pretty critical planetary geometry tomorrow with this Uranus Saturn sextile, and then also Mars participating with this in a sextile to Uranus and a trine to Saturn. So a lot happening tomorrow in terms of that energetically, a lot already happening energetically on our planet. Multiple geomagnetic storms over the past 30 days, the strongest being this G2 from that high-speed stream impact, and then look at that earthquake clustering that we've had since then. I'll keep you up to date as it relates to Earth and energies that we are experiencing at this moment in time if you subscribe to the channel. So thank you all so much for watching. Smash that like button to show your support. Again, I've been your host, Stefan Burns. I'll see you all very soon. Boom shakalaka.